All right, in this video, we're going to talk about how to name functional groups. So these are the most common functional groups that you would be needing. So the way that we're going to do this is when you have an alcohol, alcohol is when you have OH bonded to an organic compound, is is going to be there's something called a prefix and a suffix. Prefix is when you name when this part would come before the name of the organic compound that you have, and suffix is when this part would come at the end of the naming. So whenever you have OH functional group, OH bonded to somebody, it's an alcohol functional group, and the naming would be like the suffix would have OL in it. So an example would be ethanol. So whenever you look at eth, you know that it has two carbons, and you know that because of this OL, you know that one of the carbon has OH bonded to it. So you can just fill in all the rest with hydrogens, and this is your ethanol. The other functional group is CC double bond, which is an alkene, and again, it has a suffix of ene, ene. An example would be propene. So whenever you see prop, you know that it has three carbons, and the suffix is in, so it's going to be three carbons, and one of the carbon is going to have a double bond. Doesn't matter which one because it's basically symmetric. So as this carbon has two bonds already, so you would add two hydrogens here. This carbon has three bonds, so you would add one hydrogen. This has one, so you would add three more. So this is your propene. My handwriting is pretty bad, so yeah. So then we have something called an halogen or alkane, which means that one of the halogens are basically compounds of group 7, when they are bonded to an alkane. So it's represented as X, so X can be chlorine, bromine, iodine, or any other member. And here we have a prefix, halo, and then the rest of the name. You don't have any suffix. So in this case, the name is chlorobutane. So when you see butane, you know it's an alkane with 4 carbons. So it's an alkane with 4 carbons. And you know that the first carbon, as there's no number, so that means the first carbon is going to have a chlorine attached to it, chloro. And the rest is going to be like this. So this is a chlorobutane. So this is chlorobutane. So if you had 2-chlorobutane, if the name was 2-chlorobutane, what would happen is you would have the same thing, but the chlorine would be bonded here. So let me just do that. So let me get an eraser. So let's say that you don't have a chlorine there, but you have a chlorine here. So I'd number it this way, 1, 2. So the chlorine is here. So I'd say that this is 2-chlorobutane. So that's how it works. An aldehyde. Aldehyde is whenever you would have a CHO functional group bonded to it. Here, I would like to mention that the CHO, the way this is bonded is you would have a double bond with the O and a single bond with the H. This is the CHO functional group. So whenever you see this, you know that it's an aldehyde. So aldehydes do not have a prefix, but they have a suffix called L. So whenever you see a name such as propanal, so you know that because of this L, it is an aldehyde, and prop tells you that it has 3 carbons. So I can add the other 2 carbons. So notice that the 3 carbons includes the carbon of the aldehyde functional carbon. So you would add the hydrogens like that. So it has 3 carbons and an aldehyde functional group. So you would call this propanal. And then you have a ketone. A ketone is very similar to an aldehyde, but the functional group is like this. So you would have C double bond O. But notice that this carbon, if it bonds to somebody here, it needs to bond to somebody else over here as well, because carbon would form 4 bonds. So ketone functional groups cannot be at the end of a chain. They are always at the middle, or like not at the edges. So in this example, we have butanone. So whenever you see on, you know that it's a ketone, and you see but, you know it's 4 carbons. So I know that I cannot place this carbon, this group, at the end of the 4 carbons for a butanone. So it has to be something like this. So I would add 3 hydrogens. I cannot add any more hydrogen here. So and so forth. So 4 carbons, functional group. You can say that, why are we not saying butan-2-on? Why are we not saying this? Well, this is totally fine. You can say that, no problem. But notice that if this functional group was not here, but it was instead here, it was there. So if this was here, so you would have to add hydrogens here. And notice that this carbon is now having 5 bonds, so you cannot have this guy here. So you have to get rid of this. So now you have butanone. But notice again, it is still butan-2-on, because now I cannot number it from this side, because that will give the ketone functional group a higher number. I always want my functional groups to have the lowest possible number in the number of carbons. So I would number it from this side, 1, 2, 3, 4. Here are my 4 carbons, and again, the ketone functional group is in the second carbon, so I can say butan-2-on. And notice that I'm not saying 2-butanone, because the 2 should come immediately before the name of the functional group to explain where its position is. So on means the ketone functional group, so the number needs to come immediately before that term. So 2-on tells me that the ketone functional group is on the second carbon. It's never 2-butanone. This is wrong. This is not the way to go. And then finally we have carboxylic acid. The formula would be COOH. You have no prefix, and suffix is interesting. It says oic acid. So in this case, I have butanoic acid. So whenever I see oic acid, I know it's a carboxylic acid. But, I know 4 carbons. So the way I'm going to draw this is, again, COOH. This is how a carboxylic functional group looks like. This is how it looks like. You have a double bond with the O. So this carbon is going to bond to 3 other carbons, so that in total they would have 4, because I want butanoic acid, right? I want butanoic acid. So I have 4 carbons. I have the oic acid functional group, carboxylic functional group. I'm good. I'm just going to add hydrogens here. So that's it. And notice again, I cannot have this group in the middle, because if I put this group in the middle, I would be forming more than 5 bonds for that carbon, and that's not possible. So carboxylic acid functional groups are always at the ends. So this is the same as this. This is the same as this. It's just that you are seeing it from the other side. It's the same as this. And notice that I'm not writing, you cannot write OH like this here. Because when that happens, when you write it like this implies that this hydrogen is bonded to this carbon, this hydrogen is bonded to this carbon, and then this hydrogen is bonded to this oxygen, which is not possible, because hydrogens cannot form 2 bonds. Hydrogens can form only 1 bond. So the proper way to write it is to have the O here and the H here. That also says that oxygens are going to form 2 bonds, which is satisfied in this case.